Hello everyone, welcome to your first tutorial on DC circuit analysis. In this tutorial I'm just going to give you a brief introduction about a basic DC circuit. Now DC stands for direct current, meaning that current flows in one direction. In future videos we'll go over AC circuits, but for now we're just going to focus on DC circuit analysis. So I'm going to draw a basic circuit, but I'm going to draw it like this. Say we have a battery here. Let's say it's your basic battery. I don't like that, sorry. Here's your basic battery. Like that, right? Let's say this is your positive terminal, this is your negative terminal. And then I want to attach a copper wire to this. Like that. And then I'm going to leave a switch. I'm going to install a switch so the circuit is not connected, as you see here. And then on this, I'm also going to put a light bulb. I'm going to connect the light bulb to this. Let's say the light bulb looks like that. So then I'm going to connect the rest of my copper wire to this circuit. Now, here's a basic circuit. We have a power source here, and then we also have a power absorbing source here, our light bulb, what we want to power. So here's your basic circuit now. So what would happen if I decided to close this circuit right here, or flip this switch? This light would turn on, right? Depending on if this supplied enough voltage to turn on this light. Let's say it does. So this generates a voltage V. Let's call this a voltage V. And this, let's say this has a resistance R. I'm going to talk about these more in a second. This has a resistance R, and this battery has a voltage V. I'm going to redraw this circuit though. I'm going to close the switch and redraw the circuit in more circuit analysis convention. So when we want to draw a battery on a DC circuit, we generally use this symbol right here, where the long bar is usually the positive terminal, and then the short bar would equal the negative terminal. We can put them in there like that. So we have this, and then I close the switch, so there's no gaps in my wire anymore, in my copper wire. And then I said that was a resistance R. Basically all that light bulb is a resistance. So in DC circuit, or in circuit analysis, we draw resistance as just a squiggly line like this, R. And then this, it's also measured in a thing called ohms, but we're going to get that later. So let's just say this is a resistance R, and I close the circuit. The switch is on, close the circuit. So that's what we have. Now when I close the circuit, we're going to have a current flowing through this circuit, a current. Let's call that current I. Now you may ask me, hey Joe, what is this current stuff you're talking about? Well, you can think of current as just flowing charge. So let's say it's usually electrons in a circuit. Now we know from physics class that you might say, hey Joe, like electrons are attracted to the positive terminal, so why aren't they flowing this way instead of flowing the way that you drew? And you're right, electrons do flow from negative to positive, and that's what actually does happen, but in its modern convention to actually take it from the positive terminal to negative terminal when we're doing circuit analysis. I promise you it'll work out the same, everything will be fine. So we close that circuit. We have a current I flowing through this circuit. Now this current I then will meet this resistance. Now you can think of a resistance as an element that's trying, any resistance means that it's trying to impede the flow of charge. So it's trying, the flow is trying to go through this resistance, and this resistance is trying to resist that charge away. It's trying to like push it away. So the higher the resistance, the harder it is for this current to flow through this. Now when current flows through a resistance, it generates a voltage V. This is also a voltage down here. It generates a voltage V here. So as current is flowing through this circuit and goes through here, you can actually measure the voltage across this element right here. Which then, you can think of voltage as pretty much in energy, how much work it's doing. You can think of voltage, how much work does it take for this charge to push through this resistance, which generates a voltage? And that work then, in case of our light bulb, is converted into light energy, or it heats up the filament in the bulb and creates a light source. So that was basically a brief introduction to electric circuits, basic DC circuit. In the next video, I'm going to talk about energy and power and independent and dependent sources. I'll see you there.